time, hopefully. Great, welcome everyone. This is a non-technical talk about technical topics. So don't expect a load of C# code, but this is very much reflecting on the technical landscape and what we do as software engineers and whatever other technical roles you're in. I don't want to restrict this to software engineering. It is largely about engineering. You'll see as we go along what it's about. I should warn you to start with, there will be some singing. Normally I have a little look at my score for the musical that I'll be talking about before speaking, but it's been a little while. That may mean that it's a bit more out of tune than normal, but just go with it. Before we start, I pretty much always have one slide saying to be kind at the start of my slide decks. I'm sure you are all wonderful people, but it's just a reminder, really, that we can all be nudged to be a little bit kinder. And if I can help nudge the needle a tiny bit on that front, I would rather you all take away that message of kindness. And next time someone's a jerk to you, check yourself before you're a jerk back. That would be great. I would far rather you took that away than any other technical messages. We can all do better on that front. Okay, and with no more further ado, this is the first slide. So, doesn't look like it, but white, a blank page or canvas. The challenge: bring order to the whole through design, composition, tension, balance, light, and harmony. I wish those were words that I had come up with myself, but no, they are the opening to Sunday in the Park with George, from 1984 by Stephen Sondheim and James Lapine or something like that. I've never known how to pronounce his name. That's one of the works we'll be talking about, and this is the other. So this is A Sunday Afternoon on the Island of La Grande Jatte by Georges Seurat, who lived between 1859 and 1891. It took 2 years to paint, between 1884 and 1886, and it's a huge work of art. It's 3 meters by 2 meters, which I'm just looking in my shed. It's basically one whole wall of my shed. My shed does have some fine art, which will have one picture of something similar coming up, but nothing near the scale of this. I haven't seen it personally. I was hoping to see it last September. I was going to be in Chicago, but then, history happened. This is an example of pointillism, which isn't quite to say it's made up of little dots, but they are very small brushstrokes. And it was done over time with fewer and fewer colors. And basically, Seurat was playing with light and building large things from small things, building, the hat, which we'll come back to later on, from lots of different small coloured brushstrokes. So we perceive it as a hat, but it's actually combined of lots of things. This is the second piece, which is Sunday in the Park with George, as I opened with, which is a musical, which is a fictionalized account of Georges Seurat and focusing on an afternoon on the island of La Grande Jatte. I'm mostly interested in Sondheim myself, but Lapine is brilliant as well. And so far, I mostly have experience of this musical through recordings. Again, just like last year, I was going to be in Chicago and I would have seen the painting. Last year, there was going to be a production of Sunday in the Park with George in London. And then again, the pandemic happened. So I wasn't able to see it. It has currently been indefinitely postponed, but I'm hoping sometime next year I might finally actually be able to see this musical in person. But it's a wonderful, wonderful show. It was very experimental to start with. There were 25 performances off Broadway at a theatre called Playwrights Horizons in New York. And the second act, so it's probably not quite half the musical, but nearly. The second act of it was only in the final three productions, the final three performances off Broadway. So you can see just how experimental it was. I normally go into the plot in a certain amount of detail. I won't do that today just because we're relatively short of time. But I would encourage you to read the Wikipedia article, ideally play on Spotify or whatever the soundtrack. It is an amazing piece of work. I will say very briefly, it's set in two different time periods, where the first is in the late 19th century with Seurat himself and his girlfriend and a few other characters, and then the same actors in the second half play George's great grandson and the daughter of George, who is, so the character is called George in both halves, but the modern day George's grandmother, who is the 19th century George's daughter. And as you can imagine, that's all quite confusing. But this aspect of repetition is, again, experimented with. A lot of the songs in the second half are clearly based on songs from the first half. And when I say clearly, it's not always quite so clear. So the actor who played George in the original Broadway production was Mandy Patinkin, who you may not know if you're not a fan of musical theatre, but if you've seen The Princess Bride and I say, "Hello, my name is Inigo Montoya, you killed my father, prepare to die," that's Mandy Patinkin. And from what I've seen of him on Twitter and the like, he is a wonderful human being. But the aspect of repetition, there is a reason for going into this, the aspect of repetition is sufficiently subtle that at one party, an after-show party, Stephen Sondheim apologized to Mandy Patinkin for getting him to sing the same song twice, finishing the hat and then putting it together. Mandy said, I don't know what you mean. And then Sondheim showed Mandy, who'd been singing this, it wasn't that he wasn't familiar with it, that one of the songs was the same, just with a slight drop at the end. And it made all the difference. So what I want to get across is the feeling of experimentation, and this is not just a stale piece of theatre, it's something that lives and grows, and I very much want us to view software in the same way. So we're here to talk about software. I'm not just going to talk about the painting and the musical, I'm going to talk about how they relate to technology and our day-to-day jobs. I want to talk about it in terms of art, craft, and engineering. We're going to use the painting and the musical to explore code. There are a couple of tiny code examples in C#. You don't really need to understand C#, but I'm sure you will do. And we're going to think about the aspects that were introduced in that first line, the challenge being to bring order to the whole through design, composition, etc., through the lenses of art and craft and engineering. And this very poor sort of Venn diagram-ish is meant to represent the ideas of art, craft and engineering kind of interacting with each other, maybe art and engineering not quite meeting, but it's sort of for you to define. There are lots of different meanings for art, craft and engineering, and I'll give mine for today, but I would encourage you to reflect on, if someone asked you to define the differences for yourself, what you would do. So this third piece of art is from 1963, and it's a piece called Lune et Vent by Joan Miró. And I have this hanging up in, I'm not sure that it's quite this actual version. This is an hors de commerce version. I think mine is a numbered one, but I can't remember the number. But I have a print of this in my hallway, one of the original prints, and I love Joan Miró. If I showed you, if I swizzed my webcam around, you'd see 4 other ones in my shed, and I love them. But I don't know why. I don't have the understanding, the terminology. I don't have any background in fine art or education. I do know that, and yes, Peter, I have read Zen and the Art of Motorcycle Maintenance, and I completely agree that the idea of quality being somewhere between, quality happening somewhere between the painting and it reaching my eye, has the right kind of feeling for what I'm going for. But I do know that I like Miro's work, and I like the paintings from the 60s more than the more famous later ones, and also more than the landscapes from earlier. Miro had a very wide career painting lots of different things. Now, if you look at a painting like this, I could paint something a little bit like that. I could do a sort of wash in the middle. I could then do a few swirly bits of different colors and then splatter some ink at it. It wouldn't be good. It wouldn't be art, and I can't tell you why. But I can think about what kind of code is a bit like art. And the example I'll use is linked to XML. And if you've never sort of thought of a relationship between code and art before, then linked to XML may not be the most obvious of examples. But I'd say that when I first heard about some of the ideas behind linked to XML, when I first started looking at the API definitions, it sounded dreadful. So you've got implicit conversions from string to X namespace. You've got a load of methods that just take object or IEnumerable object or whatever as their parameters. And it sounds like this is going to be just terrible and very dynamic, very hard to work with, very hard to reason about. But it all just works. There's a sort of dial between terrible ideas, solid good ideas, and genius, and the line between genius and terrible ideas can be quite fine. I think probably most people would agree linked to XML is on the great idea side. Reactive extensions, I've heard opinions both ways, let's say, and opinions that have changed over time between, yeah, this was fantastic and now I can't debug it, versus, oh, yeah, no, we're using it, we're still having a great time with it, it's exactly what we need. So, coming back to art. Linked to XML has a load of great ideas behind it. Is that what makes it good art? I don't know. Is art related to the ideas behind it? What are the ideas conveyed in this painting? Is it about invention? There's some kind of relationship there, but it's hard to define. Not all art within software is in the code. There can be beautiful user interfaces, both in terms of the interaction and in terms of, just looking pretty. I tend to think that the real art is user interactions that are natural and free flowing, rather than just, well, it's got a very pretty gradient on it, for example. But unlike in conventional artwork, where novelty is, if I say inherently good, not to a gimmicky extent, but there is something, if you're doing the same art as someone else has already done, then that's less artful. In computing, novelty creates some tension. If you're trying to use a user interface that is entirely unfamiliar, that creates a really poor user experience. And likewise, if you decide, I will be artful with my naming conventions, I'm going to name everything backwards, well, your maintainers aren't going to thank you for that. I once used a piece of software called ACT with an exclamation mark, ACT 2000, I think it was, a customer relationship management bit of software. There's probably a version still going. And I hope they don't still have the same thing on the box cover, back when we used to buy software in boxes. It had something saying entirely novel user interface, and I couldn't think of anything worse. I don't want something that forces me to learn from scratch because it doesn't use any of the paradigms that I'm used to. So there's a bit of a difference in terms of how related novelty is to art in fine art and code. Let's move on to craft. So I'm thinking of craft in terms of a hard-won skill that allows the artistic vision to be implemented. And like many things in this talk, there is a really fuzzy boundary. So API design, requires craft. It's definitely tricky. And I would say that craft requires some sort of conscious study and time. It's something that matures. People may be naturally gifted, certainly, but there's some aspects of maturing over time. The whole 10,000 hours, maybe that can be disproved in various ways, but there's certainly something that you gain with experience. And just as I don't understand the artistic invention of Miro, I don't have the craft of Miro either. Now, the craft of coding can't be purely theoretical. So if someone were to read all the books ever written about software engineering, that would help in terms of the craft of software, but it wouldn't be a substitute for writing some code. It's hard to say how that can be accelerated, but I would say that there's a certain amount of pairing and mentoring. If I work with someone more junior and they propose an idea, if I just say that's a terrible idea, then no one learns anything, and they rightly think that I'm a jerk. If I say, yeah, I've tried that 3 times in my career that I can remember, that time it went really well, and here's why. That time it went really badly, and these were the consequences, and this one we still have to see. Then it's not that the experience is directly transferred, but there is some benefit from the experience that could be transferred to the mentee. Likewise, I don't want to put this all as I'm a brilliant mentor. I don't do nearly as much mentoring as I would like to. But I have learned huge amounts from many people in the industry, often when they're not even trying to mentor, but they will just drop these pearls of wisdom that are really vital. So that's around craft. And finally, engineering. Now, there are plenty of people who don't like the term engineering, and I can understand why, in that civil engineering and the like have fairly well-defined meanings that don't quite apply to software engineering, but I don't have a better word for it at the moment. What I'm trying to convey is the idea of something more objective. So if you put craft in the middle and art is very subjective, I don't even know why I like Miro, I would say engineering is the more objective side that's still influenced by craft. So I would say if API design could be regarded as craft applied to art, then something like benchmarking or testing, still, there's plenty of craft involved in testing, and build automation, continuous integration. These are all engineering tasks with varying degrees of craft. I note from the chat, the distinction between art and craft is entirely artificial. That looks like it's a quote from someone, I've no idea who. I would say that it entirely depends on how you're defining all of these things. Oh, Robert Persick, right. So I don't think it's an entirely artificial. I think there can be meaningful dialogue that draws the distinction, but the idea that we would all be using the exact same, that we all think of art and craft in the same way, that's just not happening. So with these ideas, these very fuzzy definitions of art, craft and engineering, let's revisit the musical. So how do we bring order to the whole? So we'll think about design, composition, tension, balance, light and harmony. And just to remind you, those are the words from the musical, and I have been wanting to do this talk. I've been doing this talk now for a few years and always enjoy doing it. But I had been considering it for probably a decade before, basically since I first heard the words, because this defines software engineering. Software engineering is all about bringing order to the whole, and we often, ideally, start with a blank canvas. Brownfield work is very important, but greenfield work is starting with a blank canvas and bringing order to the whole. And if you think of design and composition, you're immediately thinking of software engineering terms. So we'll look at them in turn. Let's start with design. Well, we've already got some fuzzy ideas, art and craft and engineering, and design itself is massively overloaded. the first word usage that the first meaning that I'm going to explore first is intentional decisions. So it's something is by design rather than being an accident. And in Sunday in the Park with George, so 19th century George, is always very deliberate about everything he does. He considers everything and then does it. Whereas Dot, his girlfriend, who is the woman at the foreground of the painting, is much more spontaneous, but she's the one who highlights in one of the songs the importance of making decisions. So she, at one point, chooses between staying with Georges or going off with Louis the Baker. And she sings, you've had warning, I chose and my world was shaken, so what? The choice may have been mistaken, the choosing was not, you have to move on. The choice may have been mistaken, the choosing was not, you have to move on. I find that really challenging. Have you ever been paralyzed by indecision in code? It happens to me all the time. Now with Dot, she was choosing between Louis the Baker and George, who both have very admirable qualities in very different ways. I tend to find that when I'm choosing between options in software, it's choosing between one terrible option and another maybe not quite so terrible option. They're never nice options, but you do need to choose between them. And you need to understand the implications of that choice. So we all know software changes over time. Some decisions you can genuinely postpone. You can hide them. If you're releasing, I'll give an example from Node-time. There was a type called local instant that I didn't know quite how to document and what exact operations should be on it. So I made it internal. And I thought I can always make it public later on. And it took a little bit of effort to hide it from the public API, but I did it. And I later tried to remove it entirely from the implementation and failed. It is a really key concept internally, but it's still actually very hard to define. And turns out it wouldn't be terribly useful outside the implementation. So it stayed internal. So you can postpone some decisions, others you can't. But some of those decisions that you take can be reversed and others will be removed later on. But you need to know what kind of decision you're making. And we'll talk about versioning later on. So there's sort of making a decision and making a decision about making a decision. It gets quite meta. So let's start with a method declaration and think about what decisions we have made. So literally just void foo, and you could put a couple of braces after it should you wish. So this method declaration has the following decisions. It's an instance method rather than static. It's not an unsafe method, although it could be in an unsafe context. It's not a virtual method, and it's a private method. And those last two are interesting, not virtual and private, because if this were Java code, which would look exactly the same, it would mean something different. It would be package private and virtual by default. Now, both of those are things that could be expressed. Well, there's no package private, but we could make it internal in .NET, slightly similar. So you would think that having defaults in a language wouldn't actually affect the code that's produced with the language. You could make this virtual easily, or you could make it final in Java. So you can express the same concepts either way, but people do tend to go with the defaults. And so you see a lot more virtual methods in Java, in my experience, and I haven't written professional Java beyond the last couple of days for many years. But I have tended to observe that people don't tend to make things final. And likewise, people don't tend to seal their classes in C#, much as I would love them to. I follow Josh Block's design for inheritance or prohibit it idea, but people tend to go with the default. And in some cases, like with ceiling, there's no way of expressing that I have gone with the default. If I want to have a class that is non-abstract but also unsealed, I can't use an unsealed keyword because it doesn't exist. So defaults shape our code by, frankly, us not being terribly disciplined. There's an argument for removing the defaults entirely and forcing everyone to write everything on every declaration. However, it would be really, really boring, frankly. There are a few that I would suggest could be removed. So I'd be perfectly happy if C# had said from the start, you always have to write an access modifier. So you would have to write private void foo. And in fact, I always do. This was something that Eric Lippert taught me, that if you write private void foo, it shows you have made the decision. It's not just an accident. Likewise, I tend to write, at least when I'm thinking properly, if I write a floating point literal, I will put a D, F, or M at the end of it to show this was a conscious decision to use that type. And I wonder whether if you had to do that on every floating point value, whether we might have fewer people using double where they should probably be using decimal. And likewise, I would personally prefer it if sealed were the default for classes, but at least we could make everyone specify it explicitly either way. So in some ways, I'm saying I want to make people think. And this is actually one of the design mantras in my Nodatime library. You've probably seen, I can't remember whether it's a book or whatever, saying, don't make me think. And that's probably aimed at users and user interfaces. You know, everything should just be obvious. But in terms of API design, in many contexts, many domains, certainly in the domain of date and time arithmetic, which is what Nodatime's about, there is a lot that people should think about, and there are very few obvious, this is always the right way to do things approaches. And one of the problems with .NET before .NET 6 is there are not enough date and time types. I'd argue even in .NET 6 there still aren't as many as I would like, which is why Nodatime still exists. But we will have date only and time only. And I would like to hope that the presence of Nodatime has gone a very little way into making the idea that a time only type and a date only type are useful, bringing that into popular usage. So I like making people think. And then when they have done that thinking, when they've made the decision, as Dot was talking about, I then try to make it as simple to express that decision in code as possible. So this is a second aspect of design in terms of versioning. And I have been involved in versioning increasingly in the last few years. And here we have a real craft versus engineering versus a little bit of art side of things. I've just noticed there's a comment around C# defaults. Could you view the C# defaults as being the C# designers have made a decision then that in our view this is usually a good way of doing X, and therefore that's what happens if you don't choose otherwise? It's not necessarily this is usually a good way of doing X. So take access modifiers, for example. In C#, everything is as private as it can be by default. The only time where adding private makes a difference is if you've got, say, a public property and you want to make one, usually the setter, private. But what I'd say is they've made the default safe. If you accidentally make something private when you wanted it to be public because you forgot to put anything on, you just went with the default, then the compiler will tell you about that, because when you try to use it from somewhere else, it will say, no, you can't do that. So you then go and make it public. If things were public by default, which they're semi-public by default in Java, then often something that you wanted to be private, but you hadn't bothered to express that, you don't find out until it's too late and you've accidentally released it in a package and now it's part of the public API and you can never ever change it again. So to some extent, the defaults in C# are chosen to be more forgiving of not thinking. Maybe not on the sealed and unsealed, and I'm sure that there are many different designers over time. Many different people have weighed in on this, so there will have been different reasons. But yes, it's not necessarily that it's always the right thing to do, but it's a good starting point because that can be a safe starting point. Going back to versioning, there is a craft between understanding what happens when you ship. 1.0 is a scary. 1.0 is the scariest number in software because once you've shipped it, you're stuck with that until 2.0, and 2.0 itself has implications for breaking other people and all kinds of things. But you do have to ship at some point. That is another choice. You could decide to stay safe and go 0.9, 0.91, 0.92, etc. But that's not going to be useful in the longer term. So there are lots of aspects of versioning I haven't got time to go into tonight that are really somewhere between artcraft and engineering. It's very easy to say semantic versioning says X, and semantic versioning paints everything in a very binary way. Everything is a breaking change or not a breaking change. Well, how about, okay, if I add a method overload, that is a breaking change if you happen to pass a method group, happen to use it as the target of a method group conversion, and you're calling an overload that has two different delegates, both of which are applicable for the different overloads of the original method that you're adding. That would be slightly clearer, but probably only slightly, with a concrete example. But my point is, most people wouldn't regard that as a breaking change, even though it could in theory break someone. Adding a new class or a new method could break someone because it would conflict with their own one of the same name, even if they're in different namespaces. If I'm importing the library namespace and my own namespace and I just use the simple name, then the introduction of a new type breaks things. Well, it would be pretty weird if introducing a new method or class or anything meant you had to have a new major version every time. That's just infeasible. So it's not as simple as, could it break anyone? Anything can break someone if you try hard enough. So you have to define your own, what do I mean by breaking changes? Nearly the end of design, and I need to get a move on. It's important to know which of the decisions we're making are deliberate. So I've mentioned that I say private explicitly, but you can't document everything you do. You can try to leave a breadcrumb trail. As an example of how this is important, today I deleted 35,000 lines of code. It was fabulous. I love doing that. This was an experiment effectively from 5 years ago that no one had quite got round to deleting. It got in my way a little bit, so I just deleted it all. But even trying to find, this isn't being used anywhere, is it? Well, it's not breaking the build, and we've got a pretty good build system that should find anything. But is someone using it? And I asked around and people said, no, it's okay. So we deleted it. But try to leave those breadcrumbs for decisions, including, we made the decision not to take this forward, and ideally delete the code at that point. As a great example of this, Eric Lippert, when he joined the C# team, started digging through previous language design meetings, and a lot of his blog posts go into that, saying, this decision for the new feature was made in this particular way because of these reasons. And that's really, really useful. So that's sort of intentionality in design. The next aspect of design is in terms of representation. So Sunday in the Park with George is really interested in layers of representation. So there's a representation of a real person. Georges Seurat did live, but it's a fictionalized representation. It's not meant to be biographical. And there's the actors playing Georges and other people. And then at one point, near the end of the first act, Georges sort of says, right, we're done. And the actors on stage form the picture. And suddenly they're not being actors, they're being part of a work of art. So there's all kinds of relation going on. Very little of that has to do with what most developers would talk about as design. But if instead of design, we talk about modeling and representation, then hopefully there's a clearer connection. So imagine visual art. The picture on the left here, you know, is the idea that the more accurate the representation is, the better it is? Well, there is photorealistic art, and that can be very impressive. But actually, if I want to take a photo, I'll take a photo. The artist needs to be adding some more with their craft. It can create a new view on the world, and composition and juxtaposition can capture links between objects, which individually taking photos, drawing pictures of those objects may not do much, but put them together and suddenly you've got something that's really powerful. And this is captured in Act 2 of Sunday in the Park with George, when Marie, who is Dot's daughter, played by the same actor that plays Dot, sings, "The child is so sweet and the girls are so rapturous. Isn't it lovely how artists can capture us?" Isn't it lovely how artists can capture us, how we can be represented? And in a way, software engineers do exactly that. We try to capture the essence of the world in code, the essence that's relevant to our project. So the stick man on the right here is the sort of software engineering. Well, I want a person to have a head and 2 arms and 2 legs, because that's what's important to me in this particular project. And apologies that that's a slightly ableist way of of defining a person to start with. And it can be interesting how the world can be more complicated than we can allow for. And I'll give another example for Node-time. Sorry, this talk isn't meant to be an advert for Node-time. It's just it happens to provide a bunch of good examples. A date. What does a date consist of? A year, month, and day. And if you're being clever, a calendar system, because October 25th, 2021 in the Gregorian calendar isn't the same date as October 25th in 2021 in the Julian calendar. And in various other calendars, they have different months and different years and different epochs and all that kind of thing. Great, but I think we can agree that a date has a year, month, and a day, right? That seems fairly good. Yeah, then there's the wondrous calendar system for the Baha'i calendar. I don't know much about the Baha'i calendar or the Baha'i religion, but I do know their calendar has 19 months of 19 days, and then 5 or 6 days of wonder every year. And the days of wonder are not in any month. You say, what's the month today? And they say, it isn't. How do you represent that in a date and time API? Learning about the wondrous calendar challenged my assumptions about what a date consisted of. And I think using year, month, day is fine, and we used a placeholder. I think it ends up as month 20 or something in Node-time representation, because it's simplest to fudge it a little bit to get all the other date systems, calendar systems working well. But it is interesting how all of these things, when you try to model something in software, it's almost always an approximation. Our next topic, and design and composition are the biggest topics within this talk, is composition. And there are lots of aspects to composition. And all code is composition, I would say. Software is about making big things from small things. Or looking at it the other way, we take a big problem and we divide it into small problems. And we say, well, I know how to do that bit already, or someone else has done that bit. That's fine. I will attack this problem. In order to attack this problem, I'll break it into a smaller one and break it into a smaller one, and on we go. And often, one of the things I've certainly been learning over the last year and a half as I've been doing more and more integration work is that as you add value, that's about taking things that already exist and combine them appropriately. And how you combine them is a choice. It's a point of decision. And that choice is part of what provides value in both code and art. So in the painting, we have individual brushstrokes, which are lines and dots, and they compose to form more recognizable entities. And if you've ever watched Ferris Bueller's Day Off, then you will have seen An Afternoon on the Island of Granjat, because Cameron looks at it and the camera zooms in and zooms in and zooms in until you can see the strands of the canvas. And if you use the Google Cultural Institute web app, you can do exactly that, and you can zoom right in and see the exact brush strokes, and it's fascinating to do. That's not really the traditional artistic meaning of composition. Normally it's around placement and sizing rather than individual brush strokes. And obviously that is important as well in the Afternoon on the Island of Granjat. Then I would invite you to look, and I keep on thinking I should add another slide that is the painting to show you. But picture, you can see there is this surround. I don't know whether you'll be able to see my my pointer, but this surround for the painting itself, and that was painted by Seurat. So that's another aspect of composition, that if I were physically in the gallery, there would be the wall. On the wall would be the frame. Within the frame would be the canvas. On the canvas would be this border of almost random looking. And I say almost because that it clearly reflects in a sort of almost XOR kind of way what's going on. If you look at the boatman in the bottom left, if you look at his leg where that goes off the canvas, the border is clearly different there. But there's the border, and then there's the main part of the picture. Find where I was again. So these are all aspects of composition. In code, we start with identifiers and symbols, and they combine to form statements, and then statements form methods, methods form types, types form libraries, libraries form systems, systems combine into bigger systems. And to give an obvious example, microservices and the single responsibility principle are, composition in action. That's saying we are going to derive value from splitting things up into many different parts and combining them appropriately. And maybe some of those things will only ever be combined with each other. So some microservices, yes, you might use across multiple projects. Many you won't. And there's obviously a lot of debate around the value of microservices and the costs, etc. But it is around composition. Scalability and reliability are achieved through solid engineering principles, but when you have to work out where your microservices or not so microservices end up, where the dividing lines are, I'm sure we would all love to think those are engineering decisions, but there's a lot of craft and intuition involved, I would suggest. Let's look at a second form of composition, which is the composition of data types. Obviously, that's part of the bigger picture that I was talking about just now, but it is slightly different. Where is the value coming in here? We're combining here a circle and a square and a triangle, and that composition adds meaning. Take a data type that has a start and an end, and you're calling the data type itself an interval, and the start and end are instants in time. By adding those things together and then potentially adding extra operations, so you can have restrictions and validation over them, you are providing value there. A lot of it can be really easily done, like, well, it's just a start and an end. I could have done that myself. I don't need someone providing that in a library. But saying that it's worthwhile provides value. And this is where I go into a slightly different Sondheim musical of Into the Woods. Near the end of Into the Woods, the witch sings, children will look to you for which way to turn, to learn what to be. Careful before you say, listen to me. Children will listen. Careful the tale you tell. That is the spell. And I've resisted singing this time. But the examples where you provide composition that anyone could do with your libraries, when you provide anything that isn't sort of an atomic data type, and just say, hey, I think it's useful to put these things together and you can have some operations on them, that is implying some value. So you need to be careful that the value really is there. Another kind of composition, we'll think about link. Link works well, and link to XML to some extent as well is because of this. And async certainly is, because it's designed around the idea of composition. You have operations that can compose. You can start one asynchronous operation or multiple asynchronous operations within another one, and it gets quite hard to come out of that. You know, your async sync boundaries in either direction end up being quite annoying, but where the hose and the connector have the same shape, it works really nicely. The language aspects of link and async are nice to haves, but they're not fundamental to understanding the benefits of having a system that is designed for composition. It's no coincidence that the things you can await are the same kind of things that produce asynchronous operations. All of this is kind of par for the course for any functional programmers. And you are probably, maybe half of you are thinking, oh yes, Jon's talking about monads. And it's possible that I am. I'm not entirely sure. I have never understood monads properly. Sometimes, if I'm feeling very, very clever, I can look at the definition of monads with some examples and feel I'm kind of getting around the edges of the idea. And then as soon as I feel I can grasp it, it vanishes into thin air again. I can appreciate that it's a beautiful idea without understanding the background terribly deeply, just like I love the Miro without fully understanding why. And this isn't an invitation to explain monads to me, maybe another time. So that's design and composition. The last few items within Sunday in the Park with George. I'm going to combine tension and balance, and I'm cheating somewhat because in art, tension has a benefit, but I would argue that within software, it really doesn't. We seek balance instead. I'll give an example of how tension is beautiful or can be beautiful within art. The first few chords of Sunday in the Park with George that are played while that speech of white, a blank page or canvas, the challenge to bring order to the whole through design composition. While that is going on, at suitable points, there are chords, and they're beautiful, but there's something missing. And I didn't understand until I read a book specifically about, or a chapter of a book specifically about this musical, that the natural bottom note is missing from all of those chords until the end of it, the end of that line, where we get harmony. We finally have a chord that's got the natural ground note. And as an audience, you sort of breathe a sigh of relief. You hadn't noticed that you were building up tension, but that lack was building up and everything is right again afterwards. I would argue that's not a good thing in software. There are plenty of aspects of tension, but we do seek balance between competing demands, time, different projects, paying down technical debt, the balance of maybe giving everyone an extra day off versus, well, we do need to ship this. Work-life balance is a theme in the musical and also in our daily life. In the musical, George sacrifices his personal life almost entirely for the sake of art, because the art is the basis of his personal life. And just to give an example of that, there's a song called Finishing the Hat, and it's like being in the zone. So he is focusing so much on this hat that he sings, finishing the hat, how you have to finish the hat. How you watch the rest of the world from a window while you finish the hat. Everything else is just happening somewhere else because I'm so focused on the hat. And then at the end, he sings, look, I made a hat where there never was a hat. He's created something from nothing. And I'm sure we have all experienced the joy of starting from nothing. And then I've got a tool that works. I've got a user interface that's showing me something wonderful. Look, I can show my kids. And one of the things I've been doing over the last year and a half for church, doing some AV presentation software, one of the joys has been showing it to my kids and going, do you know what? I don't like to say it, but that's pretty cool, Dad. And it's such a joy. But when it comes to our work-life balance, I do think we tend to get it wrong and go more on the work than on the life. So I would encourage you to, examine your work-life balance if you possibly can. And I know there can be financial pressures. I know there are all kinds of things, but often I think software engineers push themselves more than their managers push them. And you think, oh, I want to understand this bug before I go to bed tonight. Like, it'll be there in the morning. The bug doesn't care whether you go to sleep or not. Chances are, if you do go to sleep, your brain will be able to do something while you're asleep and improve things, give you a better chance. Light. Light in the art world is obviously very important. If we were in a user group venue and this were on a projector, then light would be really important. And even when you're just looking on monitors, what color is the sun in that slide? Is it yellow? Is it orange? Is it mustardy yellow? Different projectors would show that very, very differently. And that reflects how we conceptualize experiences differently. And the whole painting is an experiment in light. If you look at the figures in the painting, most of them are in shadow, and only the girl in the center is completely in the light, and she's looking out at you. Seurat was trying to do something he regarded as scientific. He was trying to blend light in the eye. So he would take blue and yellow and green and orange and say, well, I will put those colors on the canvas and they will be blended in the viewer's eye. It's sort of back to Zen and the Art of Motorcycle Maintenance to a large extent. But what is light in software? For the purpose of this talk, I want to think briefly about openness and transparency. We talk about shining a light on things that were previously hidden. And we can look at the rise of open source and see how that is better for things being open and transparent. And just as the example over the weekend, I don't know how many of you were watching the hot reload saga and drama within .NET happen, but if .NET had not been open source, then possibly we wouldn't have spotted hot reload being taken away from the .NET SDK, .NET 6 SDK, which caused a huge tidal wave of resentment, and it's now back in. Hooray! Thank you, everyone. I won't name individuals because I gather it was a real team effort to get everything sorted. But that sort of openness, and there's lots of discussion saying, oh, Microsoft weren't open enough about their reasons for doing things. Yeah, there's plenty to discuss there. But the fact that it was open source, I think, led to a better outcome than if it had all still been closed. So it's about being transparent and communicating clearly. It's also about a room for private things. We talk a lot about transparency, but also about privacy. I want to know everything about what you are doing as a company, but I don't want you to know anything about me. Okay, well, there are times where that's entirely appropriate. There are times where I do need to tell you something for good reasons. And I'd finally say on the aspect of light that a deluge of data is not the same thing as information. That's a blinding light. If I give you all the information but no way of understanding it, that doesn't help at all. Imagine if you're reading some code and every line has a comment on it. Even if the comments are actually fairly meaningful, and most code that I've seen with a comment on every line, those comments are not useful. They say what the code does rather than why it's doing it. add 1 to x. Well, I know what x++ means, actually, you know. However, add 1 to x, because it turns out that the thing that we're calling is 1 based and the thing that we've got it from is 0 based. That's the reason for the discrepancy. That's useful, but you don't need very many of those. And the more you have, the harder it is to seek out the gold from the dirt. So light, information, transparency, openness. Finally, this is the final slide with anything on it. I want to talk very briefly about harmony, and this is in some ways the most important slide, where balance looks at aspects that are in tension and tries to find, okay, well, you'll compromise a bit and you'll compromise a bit and we'll come to a balance. Harmony is about elements that are separate from each other but are better when they are composed together. And this isn't about code. The composition, earlier on, I was talking about code. Now I'm talking about people. How can we, as an industry, produce a harmony of people? And I think part of it is about humility. Imagine you're in a choir or an orchestra. If you sing or play as loudly as you can all the time, that will be horrible. It will be a cacophony. You need to know when to keep yourself soft, when to be quiet and let other people's ideas come through, when to amplify someone else's ideas. And in a good team, you have a good team leader who can be like a conductor, who can say, okay, we want to hear more from the flutes right now, or more from the violins, or a bit less from the brass, whatever it is. In a great team, you don't need the leader to step in to say, oh, well, we haven't heard from this person yet. A great team self-regulates with correction, but with compassion. And this naturally goes into diversity. So both two of my 3 kids play brass instruments. One plays the trombone, and one plays the baritone. And I do like the sound of brass. The album from the Brassed Off film is really good to listen to. But it's much nicer to hear a whole orchestra, usually. I can take a bit of brass, but I'm glad that full orchestras exist. We are more than just a few people, and our teams are better when we come at things with different viewpoints. And we are more than just the engineering team that is doing the coding. We are the product team that is working out what's useful to people. We are the sales team that's working out how to sell and actually make money from something, because that will feed into the product and feed into the engineering. We are the support team that helps people, whether that's users who've clicked on the wrong thing, people failing to install something, whether it's someone using our APIs incorrectly. There are hundreds and hundreds of people, and this ends up feeling a little bit like that painting with the surround. Who is surrounding your team? Or to put it back into music, everyone's work is their own melody, but my melody is the harmony to your melody, and your melody is the harmony to mine. If we don't listen to each other, then we just produce horrible noise. But if we listen to each other and adapt and tune how we're working to what other people are doing with humility and compassion, then we get something wonderful. And I'm not saying that's easy, and it doesn't fall into art, craft, or engineering, but it provides the backdrop for a good working environment, and I would say a good life on this planet. I would say we are lucky to work in an area that has such a rich mix of creativity and engineering. I have tried to persuade you tonight that software is an artistic endeavor that is grounded in engineering. I've tried to convince you that software is more than bits. The human interactions are really where it's at. We can always do more, we can always talk more, and we need to keep talking, even when I've gone for my dinner. But I'll end with the final words of the musical. White, a blank page or canvas, his favourite, So many possibilities. Thank you very much.
Thank you, Jon. That was really good. I think you should just get off to your wife, who's presumably downstairs waiting with food for you. But yeah, so I think you answering questions on the fly throughout the session. So I think the chat box is just now filling up with thank yous as opposed to questions. Yeah, mate, that was amazing as usual. Unless there are any questions, I think Jon needs to get off because he's got a busy evening. So.
But thank you. It was a pleasure to give. I always love giving this talk, partly because it is about people rather than just tech. Tech is fun, but let's go with people. Right. Good night, all, and do keep the conversation going. And see you all again, hopefully sometime in person. That'd be great.
Love to see you sing in person.
Yeah. Bye, folks. Have a good evening.
All right. Cheers, Jon. Thanks, everyone.